In this video, we're going to be talking about representing numbers with electricity. And mainly, we're going to be talking about binary. So we're going to be talking about binary, hexadecimal, and decimal numbers. So let's begin. Let's just start with the numbers that we know. Let's say we have the number 531. Why is 531? Well, what's the significance of this? What does this even mean? Well, we could say that this is the same as 5 times the hundreds place plus 3 times the tens place plus 1 times the ones place. We add them together, we get 531. So we say that this is the hundreds, this is the tens, this is the ones. And we use the information in each of the placeholders to determine what's really represented by the place value. Okay, so in decimal we have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could make any number possible. Right? We could literally represent any number that we want using these 10 different symbols. But in binary, we have a 0 and a 1. We have electricity there or electricity not there. So we have 0 or a 1. Oh, I wrote a V. A 1. We have on or a off. We have a true or a false. Oh, I messed these up. This is a 1. This is a 0. Now everything's lined up nicely. So the same thing with decimal. We could use the same idea but represent numbers using ones and zeros. So remember, in decimal we had 1, we had 10, we had 100, we had 1,000, we had 10,000. You could keep going, 100,000, million, 10 million, 100 million, billion, trillion, quintillion, whatever, centillion. It'll just keep going forever, and you could put values in each of the place values and create any number you want. Now this arises from the fact that we have 10 to the 0. We have 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, 10 to the 8, 10 to the 9, and it'll keep going like this. And we get the 10 from the fact that we have 10 symbols. We have 0, 1, 2, 3, 4, 5, 7, 8, 9. And we get the 4s, the 3, the 2, the 1, and the 0 from whichever place value we have. So let's take the same concept and generate and construct a way of making binary numbers. So remember, we have two symbols. We have a 1 and a 0. So we know that we're going to have 2 to the 0, we're going to have 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, blah, 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 blah. And these are the values within each place value. So this is the ones place. 2 to the 2 to the 1 is 1, 2 to the 2 is 4, 2 to the 3 is 8, 16, 32, 64, 128, 256, 512, 1024. Now, you probably have a phone, you probably have a PC. You know, they come in chunks of 4 gigabytes. You get 8 gigabyte, you could get 16 gigs. This is part of the reason why everything's like that. Like Minecraft numbers. You know Minecraft? Everything's in blocks of 64s or 16s, or, you know, because this is the natural language of binary. Computers, they understand these guys as their place values. Instead of ones, tens, hundreds, thousands, 10,000s, they see these 1, 2, 4, 8, 16. Now we could construct any number, and in each place value could only have a 1 or a 0. So I would argue that binary is actually easier than the numbers that we use day to day. It's just harder to decode, but understanding it is easy. Let's do an example, and I'll tell you what I mean by easy. So let's just make a little table here. Okay, let me think of a random number. 0, 1, 0, 0, 1, 0. And let's put our place values in the top box. So we have the 1s, the 2s, the 4s, the 8s, the 16s, and the 32s. And this would go to infinities, like 64, 128, 256, all the way, like, all the way. So if we wanted to know what 0, 1, 0, 0, 1, 0 is in binary, all you have to do, so easy. Take this number, take this number, and this is what I'm going to do. I'm going to take 16, add it to 2. That equals 18. Therefore, 10010 in binary is 18. Okay, let's do a different example. Let's do 101011. This is what I'm gonna do. I'm gonna take 32. I'm gonna take 8, 2, and 1. Add them together. So I get 3. Then here's 11 plus 32. That is 43. This is 43 in binary. You're adding the digits that have the ones in the place. There's ones in these places, so that's why I took the 32, that's why I took the 8, that's why I took the 2, that's why I took the 1. I have the 32, the 8, the 2, and the 1. I add them together, and therefore I get 43. I really hope 3, then that's 11. 11 plus 32 is 43, yes. I know my basic math. So, yo, binary is so easy. Like, the only fact that you need to know is the place values. And once you know that, you just sum the place values that have the 1 in that place together, and that's your number. So there's nothing really more to explain about binary. That's literally it. So now let's talk about hexadecimal. So hexadecimal is, because, yo, let's say we have a number like this. And I wanted to figure out what this was. That's gonna take a little while because I have to figure out this, all the place values, add them together, blah blah blah. To compactify this, what we do is we're gonna take every 4 digits. So this is the first 4. Let's take the next 4. This is the next 4. 1, 2, 3, 4. This is the next 4. 1, 2, 3, 4. This is the next 4. And we have the one solo guy by himself. Now, if I wanted to take this and put it into hexadecimal, this is all we need to know. I have to state down 16 facts. Hexadecimal just says 16, base 16. You have 16 symbols. So this is my first symbol, a 0. I have a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9. I don't have 10. I have an A, I have a B, I have a C, I have a D, I have an E, and I have an F. And if we were to put this in binary, this is a 1, 1, 1, 1. See, you could add the 8 plus 4 plus 2 plus 1. That's going to be 15. And I could just keep going. Let me go in order so I don't mess anything up. Okay, so this is the facts that we need. We need to know this and this. And all we have to do is correspond these patterns that I just circled to these. So the first one, 1010, what is this? That is A. So this is A. Next one, 1011. 1011, that's a B. 1010, that's A again. I get 01117, and I get the 1. So basically this number in hexadecimal is 1, 7, A, B, A. Just know these facts about binary and hex. Group your numbers into 4s. Concatenate them. And this is your hexadecimal number. Beautiful. And this is much easier to remember and deal with as a way of sharing information with other computer people instead of just sending them a string of 1010 and hoping that they understand it and could add all these numbers together. You just send it like this and it compactifies it and it holds the very same information, because you could just take this number and use this table and reverse it and just get the binary out if you wanted, because you get the 1, you get the 7, the A, the B, and the C. You take this table, you say, oh, the A is the 1010 and it's in this position, therefore it should be here. There we go. So now you know hexadecimal, you know binary, and yeah, this is cool.